Hello, this is your narrator. Actually, it's Mr. Ort, and we're going to be doing the conservation of mass video. We have got several problems I'm going to go through, and then I will leave the video up for the rest of them. But I will not walk you through and give you the answers directly for the second or the last two. At the very end of the video, there is a little helpful hint that will help you work out how to do brackets in chemistry when you're doing coefficients with bracket equations. So stick around for that. Otherwise, equation number one, first thing we do as far as every balancing equation is we got to count up our atoms. I always like to draw a little division too so I can see where the left and the right side are, or the coefficients and the reactants and the products. As we go through, we got sodium, Na, and we've got one of those. We have chlorine, we have two of those, and we have sodium chloride, which has one of each. This probably looks very similar to the other equation we did, but notice that, yes, it is not balanced. We have two yellow on the left and one yellow on the right for beads. Remember, you cannot break those apart. You cannot add just an extra bead to make it better. So we're going to have to add groups as they look on the paper. So what I'm going to do is probably add a coefficient. I think I'm going to add a coefficient by adding an extra group of sodium chloride onto our products. So as I do that, I will make sure I match the exact molecule that I'm adding. And it looks like I've got 2 groups of sodium chloride. And that's what represents with our big coefficient there. 2 as our subscript, 2 as our coefficient. And as we go back, I've got chlorine fixed. Yay! So chlorine has been fixed. But you may have spotted another problem. Now I have 2 sodium on the product side and only 1 sodium on the reactant side. What am I to do? Well, fortunately, sodium's just hanging out by itself because it's a metal. So I'm just going to add, yes, you guessed it, another coefficient. And I represent this by adding another group. Since I have 2 groups, I write down my coefficient number. And there we go. Now, if you wanted to, you could also put a 1 in front of the chlorine gas, the Cl2, because there's 1 group there. I think on the lab, it's going to ask you to put in a 1 every time you see that situation, just because the computer wanted something in there. So every time there's nothing there, it's really just 1 group. So, all right, our next problem. We have sodium plus water. And it makes a bunch of SLU, sodium hydroxide, and then hydrogen gas. So I'm going to represent sodium with a green bead, H2O. I'm going to use my classic pink and blue setup. Pink for oxygen, blue for hydrogen. I'm going to draw a little line so I know where the division is. And on here, I also have to represent NaOH. So sodium, oxygen, hydrogen. So there we go. And then H2. Boom, 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 boom. We got a group of H2. And now we do the awesome counting of the atoms. So make sure you make a full list of all the different types of symbols you see. On here, I've got sodium, hydrogen, and oxygen. On the left side, the reactant side, I have 1 sodium. Same's true on the other side. I have 2 hydrogen on the left, but I have 3 on the right. Oh no! I have 1 and 1 for oxygen. And this would be so awesome if it would have just worked out, but it didn't work out. Now I'm going to mess with coefficients. That's just the worst. So the best way I think to do it is to start off with the sodium hydroxide. And I'm going to go ahead and add another multicolor group. It's a pretty molecule, right? Look at that. So I add another group. I'm fixing this for my OCD friends. There we go. And now I'm going to represent by counting the numbers of groups. I have one group and I have two groups. And that is my coefficient. So, again, it kind of messed up some of the other things we were working with, but it did end up putting us in a pretty good spot for fixing everything else down the line. So I'm going to start off by fixing that mistake by dropping another water in. So now let's count it. I've got 4 blue on the left. I got 4 blue on the right. I've got 2 pink on the left, 2 pink on the right. I've got 2 green on the right, but then I've only got 1 green on the left. Oh no! But again, saving the sodium to the very end is probably the best way to do it, just because it's hanging out by itself. It's a single one, so it's not going to mess up anybody else's plans. So there we go. So those are all the groups I have. So I have 2 groups of sodium, 2 groups of H2O. So I'm going to put that in. There's my 2 for my coefficient. I've got 2 groups of water. I've got 2 groups of sodium hydroxide. And I've got 1 group. You can put 1. I would, when you're doing the lab, it's going to ask you to put a 1 if there's just 1 group. So just put a 1 in there for the lab. But yep, now we are happily balanced. You can double check by counting, which I already did like 30 times. But you got this. You got this, everybody. Look at this. Boom. Done. Crazy equation, balanced. All right. I'm going to do one more with you here. And then I'm going to leave the video up. I'll put some gentle, calming music on for you. But I will do one more with you. And then the other 2 I will leave up for just visual. And then at the very end here, I will give you the narrated stuff. So, again, as always, we divide it in half so we know which side is on which of the arrow. We count the types of atoms. We have carbon, oxygen, or carbon, nitrogen, and oxygen. Now we count them all up. We have 1 carbon on each side. We have 1 nitrogen on that side. We have 2 nitrogen on that side. And we have 2 oxygen on that side. And we have 2 on that side as well, with the subscript. All right, so obviously the only thing that's messed up is the nitrogen, so we got to fix that, right? Looking over on the left, I see a single nitrogen. If I add an extra group, that might help us out. But let me go ahead and make this real pretty for you. Whoa! All right, so we got carbon monoxide and nitrous oxide. I got carbon dioxide. And we got nitrogen gas. All right, so I think I wanted to switch out nitrogen. A bright orange. It looks prettier that way, I think. Makes a pop on that green. So, as we're going through, we've got our beads, we've got our models set up. Again, you can draw pictures for them, or you can use beads, or you can use pennies and quarters and like whatever you want. We're in a coin shortage, so I don't recommend that. But if you have like trash, you can represent. It doesn't matter. So right now I've got 1 group of nitrous oxide. I'm gonna add another one. Why not? We'll just try it out for fun. We'll see how Mr. Ord's brain works. So now I've got 2 nitrogen on that side. I've got 2 nitrogen on that side. That's pretty cool. And now I'm realizing, wait, that's a different color purple. There we go. So I've got 3 oxygen on that side and 2 oxygen on that side. So I got to fix that now, right? Whatever will I do? If you guessed mess with the coefficients, you are correct. So what I'm going to end up doing is I'm going to throw more groups out. I'm going to start off with CO2 just because I got a feeling And you can go from lowest to highest or highest to lowest, trying to get it back. But it doesn't matter what side you start on. You just drop in coefficients until it makes sense to you. So I'm going to throw in a carbon monoxide group. Why not? And now I've got 2 carbons and 4 oxygens and 2 nitrogens on the left. So, oh, I'm switching it. Now I've got 3 and 4 oxygen, 3 oxygen on the left and 4 oxygen on the right now. Whatever am I to do? Well, again, you just keep making groups and keep playing with it until eventually all the beads even out. So it turns out if you add coefficients to both sides, it evens out. So now I've got 4 oxygen, 2 carbon, and 2 nitrogen on both sides. And again, each group is represented by a coefficient. So I've got 2 groups, so my coefficient should be 2. I've got 1 group, so my coefficient should be 1. And now I'm just explaining how to count to 2. First there's the first number, and then there's the second. All right, so my coefficient is 2. My coefficient is 2. Two, big shock on that one. And my last coefficient is 1. There's a free answer for you. All right, so for the rest of these, I'm going to let you do them on your own, the last 2, and then I'm going to beep in again at the very end here, talking about how to work with brackets. Hey everybody, Mr. Ort here. I'm going to quickly go through how to deal with brackets when you're balancing an equation. So this is going to be a short way of doing it. So today we're going to look at nitrogen phosphate. So we've got a nitrogen with 3 phosphate groups attached onto it. If you're really fancy chemistry, and I'm going to go ahead and throw a coefficient out in front as well. And as we're going through, you just got to count the atoms to start off. And I'm going to show you how these little bracket systems work. It's not super complicated, but first and foremost, I like to start off by drawing the arrows of the coefficient for something as complicated as this, and just so I can keep everything in order. And then what I would also like to do is draw the little subscripts. And just to remind myself of how it works, I'm going to draw little subscripts to go to the letter that they are connected to. So that little subscript 4 goes with the oxygen. This outside 3, because of these brackets, actually goes to the phosphorus and the oxygen. So it goes to, they're saying that there's 3 groups of this phosphate attached onto nitrogen. So I'm going to draw that little subscript 3 to each of the symbols that it matches with. So it looks like a lot of arrows, and it is. But as we go through, this is how you're going to count it. Basically, you look at the arrows and you multiply the numbers together. So 2, that nitrogen only has 1 arrow. You trace it back, it's got a 2. So 2 times there's just 1. So nitrogen's got 2. That's a nice easy one. Phosphorus, it gets a little tricky because we have 2 arrows that are touching it now. So if we trace the arrows back, we got a 2 and we've got a 3. Well, 2 times 3, and I'm going to label these for you. So 2 times 3 is 6. Yep, you got it. So there are 6 phosphorus in this equation. And then finally, we've got oxygen. And man, this is a mess. So that's a 2 arrow. That's the 3 arrow. And this one's actually got a 4 as well. So you actually multiply all 3 of those numbers together. So 2 times 4 is 8. And 8 times 3 is 24. There we go. And that's how you do it with these bracket systems. Hopefully nothing super crazy. But when you start getting into like really hardcore equations, this stuff does get a little tricky. But that is our final numbers. All right, hopefully it helped.